Okay, page 6 starts with one that's a little tricky. Notice what's missing out front here. I'm going to write this in pencil because it's not actually there, and I'm going to need to erase it. There's no request for the derivative. All right. So if the derivative symbol was out front and wrap this in parentheses, then right away we'd replace the x in for t and circle a as the answer. But unfortunately, there is no derivative symbol. We didn't really go over this in class specifically, but I know that you could figure out what happens here. All right, we actually have to do a fundamental theorem. We have to take the antiderivative of the sine of t, which is negative cosine, and it needs to be evaluated from 0 to x. All right, so we plug the x in first, so we have the opposite of the cosine of x, and then we're subtracting the opposite of the cosine of 0. The cosine of 0 is negative 1, so we have the opposite of negative, the cosine of 0 is 1, not negative 1. So we have the opposite of 1. So this is really saying the opposite of the cosine of x minus negative 1. Sorry about that. Cosine of 0 is 1. This negative makes it negative 1. We're subtracting the negative 1. We have a double negative there. So it's negative cosine x plus 1. It's a lot of negatives. That's not one of the 4 choices, but if we rearrange addition, which we're allowed to do by the commutative property, we put the 1 first, and what we're adding to it, which is the opposite of cosine x second, we can see that the answer is D. With 17, let g be this function. The first derivative, g prime, is equal to this integral right here from 0 to x of e to the t squared dt. Which of the following must be true on the interval from 0 to 2? All right, from 0 to 2, well, what's happening here? We're interested in g is increasing, and the graph is concave up, or decreasing. So we have to look at increasing, decreasing concavity. Okay, so for starters, what does this graph look like? Okay, so we're going to bring out the calculator. Let's get that on the screen there. Let's just ignore the integral for a second. Let's take a look at the graph, which is e to the negative x squared. Okay, if I graph this, just do a zoom 4, there's the graph. It's an e graph, and it's basically just looks like a random hill in the middle of a field. Okay, well, what do I know about this? From 0 to 2, so window, 0 to 2. There's my graph of E. All right, so when I'm going to G prime, all right, whether I want G prime of 1, all right, which would be the integral from 0 to 1 of e to the negative t squared dt, all right, well, that's just going to add up all the area under the curve, but the area is going to be positive, all right, integral is going to be positive because the region is above the x-axis. If I want to go to 2, or any number in between, it's the same thing. It's just a 2 there. We're just adding up a little bit more area. So what we know here from all this is that G prime is positive because it's measuring the area under the curve, and that area, that region, is above the x-axis. Well, what about G double prime? We need to know that for our concavity. Well, we can get G double prime real quick. We take the derivative of this accumulation function. So G double prime is equal to e to the opposite of x squared. And again, this is a function where it's e, and it doesn't matter what e is raised to, e is always positive. So G double prime is always positive as well. So G prime is positive, which means the function's increasing. G double prime is positive, which means the function's concave up. So our answer is A. Okay. 18, much quicker. We need f prime of 2. Here's f of x. Let's get f prime of x for starters. That's a quick one. We're used to these by now. We replace t with the upper bound, which is just x. No chain rule. Boom. There's f prime of x. We're asked for f prime of 2. So plug in 2. 2 cubed plus 1. 2 cubed is 8. 8 plus 1 is 9. The square root of 9 is 3. Okay. Number 19 is like one of the ones we did at the very end of the lesson there. I believe it is big G is an antiderivative for little f. Big G of 2 is equal to negative 7. What's G of 4? Okay, well, the new value is equal to the old value plus all of the change from the old x value to the new x value. And what's the change? The change is the derivative. Big G is an antiderivative for f. In other words, putting that into math is have that statement, which also means that big G prime is equal to f. All right, so if we want the change, we want G prime. Another way of writing G prime is just f. So we need an integral from 2 to 4 of f of x dx. Or, well, they use t. All right, so we know that those are out. All right, and then we just need to add to that G of 2. G of 2 is negative 7. So we want negative 7 plus the integral from 2 to 4 of f of x dx. Well, this is negative 7 times. We want negative 7 plus. So our answer is D. And again, it doesn't matter t, x. That's the general idea.